Okay, now this should all work. Can you hear me? Yes, you can. My talk is called How the openEO project unifies access to big Earth observation data processing platforms. And I will come to what that means in a second. As I said, I'm Christoph, that is him himself, and this is Matthias Mohr, who is working on this project full-time in the Institute. And is doing lots of the core work. The idea of openEO is to develop an open API that connects various clients to big Earth observation cloud backends in a simple and unified way. It's about various clients and various backends, and the idea is to make the connection between them standardized and as easy as possible. When we say we are doing that, I mean the openEO consortium, which consists not only of the University of Münster, but also the universities of Wageningen and Vienna. And there are a couple of other research institutions from several countries in Europe involved. And this is all funded by the European Union's H2020 program. Why do we do this? Earth observation data has become too large to download in the last couple of years. And even if you were able to download it, it would be just too big to handle it on your little laptop. So you need more advanced computational capacities. So that's the reason why Earth observation processing solutions are increasingly becoming more cloud-based. And these cloud-based solutions pop up like mushrooms. So there's the DSs from the Copernicus program. There are the thematic exploitation platforms by ESA. There's Google Earth Engine. There's Sentinel Hub, GeoTrellis, Rasterman, just to name a few. And so there's lots of them. And the analogy to describe the motivation of openEO that I've been told has to do with GDAL. So may I ask, who of you knows GDAL? Please raise your hand. Yeah, that's what I assumed, pretty much everyone. Do you know the time before there was GDAL? Michael do, but well, I don't, because that was way before I was born. But anyway, I've been told that back in the days, each GIS system had its own database, and only that system itself was possible to talk to that database, because it was all proprietary and no interconnection existed. Then, maybe a decade later, file formats were introduced. So, like the shapefile of ArcInfo or GeoTIFF, and different GISs could access different file formats depending on whether it was implemented for them or not, etc., etc. And then there was GDAL, who introduced that abstraction layer, so that any of those GIS could just implement GDAL, and then through that you could access all of them, and that made things a whole lot easier. So when you look at the Earth observation cloud backend landscape these days, it's pretty much like this. So there are different backends, and each of them has their own database where it has their data and does their processing. And I think it becomes quite obvious from this that if I go back a couple of slides, that looks pretty much like that. And so openEO thought, why don't we just skip this mess and just do it right in the first place? So from this, we would like to go to that. So that all the backends have that one abstraction layer, openEO API in the middle, and can be accessed by different clients. And the ones we cater for at the moment are R, Python, and the JavaScript library for web stuff, or Node, or whatever. So then, of course, this situation where each of the clients has to talk each language, which is indicated by the colors here, becomes a situation like here on the right-hand side, where there's just one language needed so that every client can talk directly to any backend. Why do we do this? I said these points before. Another point that is to combine different backends into one workflow or process. So if different backends have different things on offer that you would need, having that one common language makes it a lot easier to combine that into your workflow. Extensibility, so that you can teach a backend your way of doing things. I will come to what we mean with that later. And one important thing is to compare or validate the results that backends export. So you could, if you have a common language, you can run one analysis on one backend and then rerun it on a different backend. And if they produce the same result, then you've reproduced this result by a different method. And that's the thing science is all about, really. And this can help to build trust in the workflows scientists do and in the results they come up with. And so far, from all these backends that are listed up here, Google Earth Engine really is maybe the only feasible offering that there is in terms of being easy to use and being available now. So some say that Google Earth Engine is the only place where one can get things done at the moment easily. And what happens if this is still the case 5 years from now? The problem is that Google Earth Engine is not open, so you can't see what is inside, and you rely on Google running it and running it for free for you. And if there was an open source solution by the community, that would help things a lot. And we think that this common interface between backends can indeed help upcoming backends to or service providers to gain momentum and ease the transition between the existing Google Earth Engine workflows and maybe newly more open options. So how do we do all that? So what we are doing is we define a core API that should design the language that should be used between the backends and the clients. We do this in a RESTful API with JSON bindings, which is the state of the art at the moment. And we implement reference implementations for that. So we've got the free clients libraries I mentioned for R, Python, and JavaScript, and we build drivers for 7 backends. So we build a piece of software that translates the openEO code into the code the backends understands. And really this implementing thing is what openEO is about. So we not only come up with a theoretical idea, but we actually do it practically, because having running software available is what gets things done. And that's why we put in the main focus on that. We also define a process catalog with processes that should be available on backends or could be available, from stuff like minimum maximum to band math to more complex things like computing an NDVI or stuff like that. And everything we do is open source. So if you go to GitHub, you can download all the stuff we do there and use it for free. Let me show you a little live demonstration of the things we've got there. So I will. You can't see that yet. There we go. So that is the starting page of openGeoHub, which is the piece of software I constructed within this project. So I work as a student assistant, and that was pretty much my bachelor thesis. So what this hub does, nightly it crawls all the backends that there are at the moment and collects the information about what they offer, so that someone who's interested generally in openEO can have a look at what is available, what can I do. So there's 6 backends here at the moment. And I will show you the Google Earth Engine one because that's the driver that is most complete at the moment. As a project, we are still work in progress. So there's a little description here, and then the hub displays which functionalities of the API are supported by this backend. So which authentication methods are available, whether you can estimate the processing costs that a certain query would cost you, because we only also cater for paid services, because otherwise these paid services may not have an interest to support openEO. Whether you can store your own files there and work with them. Validating user-defined functions is about uploading your own R or Python scripts and including those into a workflow. And well, not all backends support everything, so that's what this hub is for, to get an overview. You can list all the collections that, or data sets that the backend offers. So, for example, here you've got an Australian 5-meter digital elevation model that is within Google Earth Engine, and you've got the spatial extent that is covered, so it's about Australia. So you can get an overview of which data you can work with. You can also get an overview about the processes that are available, because not all processes have to implement all processes of the process catalog. But here you can see what does add_dimension do, and see all the parameter things. And this is intended to make developing openEO process graphs more easy. This process graph is the core thing within the openEO project speech, so that defines a workflow from getting the data to analyzing it to outputting it, and I will show you one process graph in a minute. But before we do that, you can also see which output formats are available and which service types are available, maybe to see, so for example, service types means something like WMS, and this client here, for example, offers 82 output formats, I think because they've got some GDAL thing running in the backend. Billing information, as I said, catering for the paid services as well. I promise you to show you a process graph, so I will open this backend in the openEO web editor and log in. So that's a web app interface that uses that JavaScript client API to talk to the backends, and we implemented that so that anyone can just play around with a backend, and especially also to make development easier, because in here you can now search for collections. So I will just enter S2 for Sentinel-2, and then I can just drag and drop this data set over here and start doing things with it, like, for example, filtering it by a polygon. So when I have both of these in here, I can draw an arrow from here to there to the data, and for example, select the bands that I would want to have here, like rain, for example, or select only one time interval that should be included in here. Yes. But I won't click together one now because that would take a bit too long. I have saved the process graph down here that calculates the minimum NDVI for, pretty much if you want for the whole world. So that uses the Copernicus Sentinel-2 imagery, runs a normalized difference process on that, reduces that to the minimum in the temporal dimension, and then applies a linear scale range so that the output is mapped to 0 to 255 so that you can see it as pixel intensities, and then saves that as a PNG. And I can now just click here, and now this process graph is sent to the Google Earth Engine driver, which is running on an Institute server, and that translates it to Google Earth Engine script, and sends that script to the actual Google Earth Engine server, somewhere in the United States probably. There this script is processed, the results are sent back to the driver, which forwards it back to my computer here. And you can see now building that up. It looks a bit dark on the with the beamer here, but if I make it a little bit transparent, maybe you can see that the NDVI is less on the Ruhr area and along the Rhine area, the Rhine Valley here, and is obviously bigger in the Black Forest area, for example. Yeah. And in theory, I could just take this process graph and run it on a different backend as well, and I should get the same result. Back to how this all works internally. So we use existing standards where possible within our API. Can I have that? Within our API. So as I said, it's RESTful. We use an openAPI document to describe it. This was previously known as Swagger, that's the more familiar term for you. You can output GeoJSON. We use OpenID Connect for authentication, all these little things. What we don't do, we don't use the web processing service standard, that is an OGC standard, which seems like the most obvious solution to solve this problem when you read the title, but sadly it doesn't support chaining the process together like you just saw that in the process graph. So there you would have to run one piece of a process graph, store that, get it again, process that, and that would not be feasible for the big amounts of data and the kind of processes we've got in mind. But there is a driver for WCPS services, so that you could access that. So that such a driver sits between the openEO API coming from the clients and the existing cloud backend here, and this works without really touching the existing cloud backend, so you can just put that adapter in between, then it works. The results that you get can be exposed via any web service like a WMS or just a tilemap server. The whole API is compliant to the upcoming OGC API Core API Commons part. And we are very involved in developing STAC, which is a new metadata standard for data discovery and stands for Spatial Temporal Asset Catalog. So that is very helpful for us so that backends can describe the data sets they've got on offer. So what we had 1 year ago was these 3 clients, 7 backends, and they could run process graphs for 3 use cases with a handful of processes, and over the last year we've increased that a lot. So we completely reworked our process graph structure because we realized you couldn't really do parallelized processing with callbacks and stuff like that. So the reducer, like you saw before, would not have been possible this way. Now you can also output multiple results. You can use process graph variables in case that data collections have different names in different servers. You can insert variable for the actual name, things like that. Then, of course, we had to adapt all our client libraries and backend drivers to that new version, and we are still a little bit in the process of doing that, but more and more things are done. Yeah, compatibility, I said that. And our process graph catalog now includes more than 100 processes, which are very detailedly defined by Matthias. So we put a lot of work into selecting the processes that are needed and defining them in a way that they are not ambiguously interpreted, and in the hope that the backends implement them as detailedly as he told that, so that indeed this vision of having the same results on different backends can become reality. And UDF is this user-defined function that I mentioned a little bit earlier. So we have reference implementations in R and Python for that, so that you can, if you find that the existing processes don't match what you need, or you need more programming logic, you can take your existing R script or Python script and upload that to the server. The server runs it in their sandbox on their data, so that your code comes close to the data and you don't have to send that data all around half the globe. And yeah, that's a pretty big thing. Maybe Etzer could say more about how that has been done. Yeah, my lessons learned personally by implementing that openEO was that, well, you can specify things as clearly as possible, but the programmers don't really read the docs. They just think, yeah, I think it was this and this way, I will just return this in my API, and then I try to crawl their stuff with my hub, and it all fails. And yeah, but we had very much feedback on that, and so I could help them to sort their issues. Describing all those processes takes time. Matthias worked for weeks on finishing that process catalog. But in the end, standardizing these algorithms and how they should work, that is feasible. What is less feasible and more hard is to standardize the data. The first thing is this non-uniform naming I mentioned before, that on one backend, the same collection may be called Sentinel-2 and the others call it Copernicus S2, and the third one calls it a different name. But not only the naming is different, sometimes also the content is different. For example, Google Earth Engine puts all the Sentinel-2 imagery into one huge thing, but in doing so makes a few assumptions on, for example, which orbits you want and stuff like that. And if you're a more scientific user, you may want to have more control over that. So this idea of taking the same process graph and running it somewhere else not only depends on the things that are about the processes, but also about the data that is in the actual backends, and that's the issue that is a bit harder to tackle. Still to come, implementing all these processes of the process catalog in all the backends, full compatibility to the newest API version, and getting it all ready. That are the things that are in the pipeline. Some challenges that are upcoming next to that uniform naming is incorporating everything into one API and not forgetting a use case that would make openEO not a feasible option for some within the domain. But we dropped the idea of including everything, like the payments for the paid users, commercial users. They've got to say, work that out themselves. We're not going to include a huge payment API within openEO because it's really out of scope. Those user-defined functions are still being worked on. Efficient access to big data via the data cube concept applied both to raster and vector data. Again, that's a thing Etzer is working on and could tell more about, so ask him if you want to know something about that. Validating the backends against each other, reproducibility. There was a master thesis that explored how things can be compared, because even if files are not identical byte by byte, they may still have pretty much the same results. And for the commercial providers, the cost estimates are more difficult to determine than we expected. So we expected that if we ask them, what would this process graph cost if I would run it on your backend, they can't really say it, at least until now. Challenges for the project itself are that we need users to adopt this, and not only clients, but also the server. So we've got to convince backend providers to include openEO in their infrastructure. We try to minimize their effort as much as possible by writing those drivers ourselves for them without them having the need to touch their system. Yeah, that's still a hard thing to do, and we can't do it for all of them. So there are certainly more backends out there than the ones we address, but we can't solve it alone for everyone. So what we hope will happen is that this all becomes a community project in the end, like GDAL became, and that this project sustains itself, because we've only got one more year to go, and then the project, well, as projects are, it's meant to end. We've got some big players on board, like Google Earth Engine or the Sentinel Hub by Synergize. So that's one thing that gives us hope that it will continue. Next to that, some of the consortium partners will actually use openEO in production on their systems, so they will have an interest to maintain it. And if you as users, we want to make openEO known to you as well, and that's why we are on conferences, holding workshops and hackathons like this afternoon, where you can get your own hands on openEO, and we hope that you will like this new option you've got. So yeah, thanks for your attention, and let me know your questions if you've got any.
Any short questions to take right now, or?
That does not seem to be the case. Well, you will have the option to go to that hackathon this afternoon and get your hands on, and maybe then there also chat to me or Matthias.
Yeah. Listen.